Alright, fun stuff. Remember back in the day when you had to make little graphs, draw things out, and we got these wonderful calculators. Drawing and interpreting a scatter diagram or scatter plot, however you want to go through and say it. The reality is, as you get to dealing with more real live data, the more technology is going to come into play as a useful tool for dealing with this. I mean, yes, can you go through and draw this out on a grid and put this information out there? Yes. What we're looking for now is more the interpretation. Can you take what you've got and actually come up with something? So, use the graphing utility to go through and draw out the scatter diagram. Now, what's nice about this is if we can go through and do this, we can also use the graphing calculator in this case to go and come up with a probable equation for us to go and answer questions about this. Now, if we take a look at the data here, it says runs scored versus on-base percentage. So would you expect to see this increase as your on-base percentage increased? Well, think about baseball. If you can't get on base, you're going to be able to score a run. So the higher your percentage for getting on base, you would think that the higher the runs scored would be, correct? So it's a logical type of system, is it not? You can kind of see where it goes. You can kind of make predictions. Now, one of the things that we need to be able to do is kind of figure out, is something linear or not? Well, A looks sort of kind of linear, right? B looks sort of kind of linear. Does C look kind of linear? No, not really. So when we start taking a look at how the data is on there, we can determine whether or not something is a linear or non-linear. Okay? So obviously when I take a look at figure 8 here, it's pretty easy to go and figure out what's linear, what's not linear, so on and so forth, right? And if you see a shotgun pattern on there, is there anything that you can determine from it? No, because it's just big circle stuff. Not really. I mean, it does seem to have a little bit of a linear component to it, but as I'm going through this, I see that, okay, we're going fine, and it seems like it curves up here, it has a little bit of a curve down here. So while you could put a straight line into it, it really wouldn't tend towards that. Now, you can also look at this one here and say, well, gee, it's kind of curvy in there, isn't it? But in general, it's going down. There's more of a pronounced curve with this. Okay? But, sorry. Okay. So, finding a linear model. There are many different ways of doing this. This is probably the most inaccurate method that I can come up with. And the reason why is because it goes on personal interpretation of what you want to do to select the 2 points. So if I take a look at the stuff here in table 6, I mean, where do I want to go? Do I want to go through the center of the data? Do I want to go where I see more of the data in a straight line? Do I want to go above or below? I mean, yeah, generally drawing it through the center would make sense, right? But I could have picked this point here, picked that point up here. That would have done it, right? Or picked this point and that point there. So like I said, there's got to be a better method for doing it and being more consistent. Now, the points that we've got, we've done this before. We put the data in. We've gone through and done the stat plot and come up with an equation for it. And that is what you generally should use. That is going to be identified as our line of best fit. Okay? So, when we go through and do this, one thing that you want to make sure that you do is turn your diagnostics on. Because whenever you reset your graphing calculator, diagnostics will be off. And that diagnostics on is second catalog. And you got to go through and figure out where that's at. So, well, I had it. I'll put the catalog stuff back up there. I just got to get rid of somebody's terrible attempt at multiplication and mathematical humor. Well, if you cancel out sine x over n, you cancel out the n's, you get 6. It does not work. Okay, but you get second, and go down to 0, which is the catalog. Then you use arrow key down until you run across diagnostics on. And you want to make sure that you have that turned on. That way you can get your correlation coefficients, which will kind of help you in determining how good of a fit you got. So diagnostics on, make sure that's on there, enter, enter. So once you've got that turned on, we can put the data into stat plot. So let's go run through that. Make sure that we get all that squared away again. So we're going to go back up here to the data. And you always want to identify what's going to be X, what's going to be Y. Okay. So it says on base percentages are X, run scored is going to be Y. So press stat, and you go to edit, and L1 is always going to be our X data in there. So we should be able to put in that. It does take a little bit, so. Okay, so somewhere I screwed up because okay. Now, mind you, it should make sure that it matches out. I'm off by 1 somewhere. So I gotta see whether I added 1 extra or if I missed 1. Okay, it's supposed to be 7, 7. Now, would a spreadsheet be easier to work with? Possibly. And there are always others out there. Here's supposed to be 3.6. Okay, so now I've got everything matching up. Stat, calc, and we want to go down to number 4. Calculate. And so it comes up with our equation. So, I was going to say, does everybody's numbers kind of match up with what I got? Yes, no, maybe so? Because, yeah, now I'm looking at what I've got here. No, I've got something really far off. Okay, so stat, edit, 34.5, 35, 33.6, 32.3, 33.2. Ooh, I see one that's really throwing it off. This is supposed to be 7, 7, 9. Enter. Make sure I got everything else 3 digits. Okay, so quit, stat, calc, 4. Yeah, that's better. It's closer, right? So, we've got that equation down for us now where we got y is equal to 40.85x minus 6617. Now you'll see the correlation coefficient here is 0.75. Is that good? Not really. Because if you take a look down here, the correlation coefficient should be between -1 and 1. And positive means positive slope, negative means it's negative slope. But the closer to 1 that you've got, the better your model is going to be. So it's okay. It's within tolerable limits, but it's really not a good model. Now, does that mean that there could be a better one out there? Maybe, but it surely ain't linear. But if we take a look at the data, the data was kind of in a line. Now, to do the rest of this stuff, what you always got to do is make sure that you write that down so that you can put that into the line of best fit. So here we go. First thing we're going to do, y is equal to, we're going to put in that equation of 40.85x minus 617.66. Window. Okay? Obviously based upon the data that we've got. Now, the percentages are supposed to be on the x, correct? So I suppose I could put 0 down and I could put where'd it go? To 100. Okay? Would that make sense? Possibly, because I mean you're talking about percentages. But we don't have anything that was anywhere near 100%. But if we want to try and predict where it's going, that might be a good idea. So, y minimum? Well, if we take a look back at our data here, the lowest value that I see comes down here is in the 637. So if I put my y minimum at 600, okay, y maximum, let's see, we're over 8, so I'm going to put it in as 900. So I want to make sure that I got a window that's going to fit the data. Next thing I want to do, second, y equals, I want to make sure the plots are turned on. So we got 1 here, so I'm going to press enter, flashing on the on, press enter, so now on should be flashing. And now if I go and hit graph, I should be able to see my data, and I see the line coming through. Right? Now remember, we had this percentages set to 100, right? 0 to 100. Now the lowest percentage that I see here doesn't go below 30, does it? And it doesn't go beyond 37. So if I were to go and change my window and set my Y or my X max here to say 30 to 40, and I tell it to graph, would I get a better picture of what's going on? Okay. So if I look at that data, it's sort of kind of maybe linear. Although a curve looks like it might actually help, but if I had a curve in there, would that make sense to as you're growing larger? If it was a curve that was going up and down like a parabola that had a peak on it, that wouldn't make any sense. It could become some kind of a screwy quadratic that go up and down, up and down. But that still, the more you have, that is not really going to go backwards, right? So, kind of gives you a way of predicting some of the behavior that's on here. So, let's try this. Oops. So, how many runs would be scored? It's asking the question if you had an average of 40.85. Well, it's an average increase of 40.85. So if I wanted to find something further out, do a trace on it. Say I wanted to know what would happen if we were running at 39%. Trace. I put in 39. So if we were at a 39% average, it would tell me that we would score probably 975 runs. Does that seem reasonable? Possible. But this is what we can use this type of information for. That's how we go through. So I'm going to let you guys get to the